So, totally lost the first video I did. Not quite sure what happened. I was trying to use a different camera. Apparently it didn't work. So I'll do this again. I'll go over these notes. You can see we're talking about spheres. Spheres are 3D circles. If you remember, a circle, the definition was the set of all points equidistant from a center. So if this is the middle, every point on the edge is 5 away from that middle. So radius 5, radius 5, radius 5, radius 5, radius 5. A sphere is the same thing, but 3D. So radius 5, radius 5, radius 5, radius way up here, 5, radius down there, 5. This one would be a radius of 5. So now instead of just going, left, right, it's left, right, up, and down. The surface area formula isn't too bad. Basically, it's just 4r squared pi. What that means is, if you have a sphere, right? There's a big circle in the middle. It takes 4 of those middle circles to wrap around the whole outside of this. Exactly 4 of these size circles will fit around one sphere, in every sphere. So, if I gave you a circle, and by a circle I mean a sphere, with the radius of 4 meters, you would just simply plug it into this formula. 4 radius 4 squared pi, which equals to 64 pi, which when I put it into a calculator, it got 200.96 meters squared. Volume. It's a slightly more complicated formula. It's 4r cubed pi divided by 3. Remember though, you're going to get this formula. You're going to get a formula sheet on your quizzes. You just have to know how to use it. So it's 4 parentheses 4 cubed pi divided by 3. Just as a note, if you forgot, since it's been a while, in a calculator, if you have one of the blue ones, to do this, it would be 4 cubed. If you're using your phone, you have to turn it sideways, and then you would put most likely 4x to the y 3. That's how you do it on an iPhone. So I would urge you to use a normal calculator. It's a lot easier, but I realize not all of you probably grabbed one from school or have one at home. So 4 times 4 cubed pi divided by 3 is 256 pi over 3, which equals to 268 meters cubed. Now, something that I forgot to say many times so far, but I won't forget now, is that in the past, I've had students who would do something like, oh, meters cubed, and they would cube their answer. Or they'd say, oh, meters squared, they'd square their answer. Please don't do that. Just remember, this meters squared literally just means it's a square that's 1 meter. By 1 meter has an area of 1. Meters cubed literally just means how many little cubes that are 1 by 1 by 1 meter fit into it. So, remember, so for meters squared, you're talking about how many of these squares fit in. For meters cubed, it's how many of these full cubes. And, I'm not obviously going to cut this whole thing off, but if I could cut this cube off, that's what volume is. How many of these cubes fit into this circle? So that's not too bad. It gets a little more complicated when we start talking about semicircles and some other stuff. I'm going to start with volume. Volume's a little bit easier in this case. So, by semicircle, I mean a hemisphere. A hemisphere is a half a sphere, right? Literally, you just could take this normal formula, which is 4r cubed pi, and we only want half of it, cut it in half. So if we have a hemisphere with a 9-inch radius, you're just going to use the normal formula, 4 9 cubed pi divided by 3. Then, we're going to just divide that by 2. I would do that in 2 steps, obviously. I would do this first, 4 9 cubed pi divided by 3, and you'd get 3052.08. Then in the calculator, you'd cut that in half get 1526.04 inches cubed, because it's volume. Surface area of a hemisphere is a little bit more complicated, right? Because let's say we have this, right? We've painted this whole outside. It's nice. We know how much paint it takes to go inside and outside, which is 4r squared pi. Now, cut it in half. You divide by 2, cut in half. What part of this, though, now doesn't have any paint? And this is where someone would have said, oh, look, the bottom. So if we painted this whole outside, right? But now that we cut it in half, this bottom part doesn't have any paint on it. So now we have to add in that bottom circle of paint, which is r squared pi, because that's the formula for the area of a circle. So you got to be very careful for the surface area of a hemisphere, because you can cut it in half, but you've got to add in that bottom circle. You end up getting 3r squared pi, which is a formula you can memorize. But I think it's better if you just remember, cut it in half, add another circle. You end up getting 763.02 inches squared. Okay. Don't forget, I'm not going to give you this formula on a quiz. You'll get the surface area normal volume formula. You will not get this one, so you'll have to derive it yourself. Now, I have not given you a lot of notes on these combination of shapes, just because I'm just kind of curious to see how people do and see if you ask questions. But, it's like 10:41 at night. Figure I need something to do, so I'll do one of these. It's a cylinder plus a hemisphere on top, right? This is the formula for the surface area of a cylinder. 2r squared pi plus 2rh pi. What you need to remember is that the 2r squared pi stands for there's a top and a bottom. So there's two circles, which is r squared pi, plus 2rh pi, which is this part around here. Right? Oh no. So r squared pi, 2r squared pi. This outside wrapping part, 2rh pi. Right? Plus a hemisphere, which is 2r squared pi, which, if you remember, this 2r squared pi was the part that's cut in half, plus the bottom r squared pi. Now, the reason it's good to know what these formulas mean is you can save yourself some time. We have this here, right? If you think about it, though, there's a bottom that can be painted. This top part is going to be ignored because it's covered. So we don't need 2r squared pi. You only need r squared pi just for the bottom. That's why it says ignore the top of the cylinder. So you only need r squared pi plus 2rh pi. Plus the hemisphere. We've established that this part here is the 2r squared pi. If you think of the bottom, though, it's covered up too. It's not going to get painted because it's on top of that cylinder. So you don't need that. So if you were just going to do this problem, the easiest way is to know what the formulas mean and to ignore the parts you don't need. And yeah, that's all there is for volume, surface area, 3D shapes. So, good luck doing your review, I guess.